Hi guys, welcome back to the channel, and we're going to be doing our examples from the New Century Maths Advanced textbook, exercise 1.03 on adding and subtracting SURDS. So for this tutorial, we are going to be doing the last three questions of questions 1, 2, and 4. So with all that said, let's get into it. Alright, so question 1, simplify each expression. Now again, we're doing the last three, so we're doing J, K, and L. So let's get started with J. Now, immediately I can see that all of the questions in this, all of the mini questions in this question 1 are all using the same SURD. So 5, 5, 5, 10, 10, 10, and what's this one here? 3, 3, 3. So we don't have to think too much about simplifying, but we do need to remember our rule that they need to be the same SURD in order to plus or minus them. Now we can see that these are all the same, so all we need to do for this first one here is we need to remember that if there's nothing in front, there's an invisible 1. So there's a minus 1, there's a plus 7, and there's a 4 in here, a plus 4 in here. So 10 root 5. So that's our answer for the first one there. Okay, so then we're going on to our next one here. We can see that we have a plus 8, so plus 8, a minus 5, so keep note of that minus 5, and a plus 3. Okay, so what is 8 minus 5 plus 3? Okay, so that'll give us our amount of root 10s here. And as we can see, it is 6 root 10. So we might think that that's done, but we still have a little bit of work to do. So think to yourself before you finish writing your answer, is root 10, the number in your SURD, fully simplified? So basically what you've got to ask yourself is this number here a prime number? But as we can see, 10 does have factors, but these factors I'm going to use here are going to be root 2 and root 5. As we can see, these two here are both prime numbers, so therefore we could write this answer as 6 root 2 root 5, but the better thing to do would be to write it as 6 root 10. So we've checked it, it doesn't need to be written in a different form, so that is all good. 6 root 10 is the correct answer. So L, what have we got now? We've got the same thing, we don't need to worry about changing them into different forms. So we have here a plus 10 root 3, a minus 3, and a minus 12. So again, they're trying to trick you with this minus 12 here. So what is 10 minus 3 minus 12? That'll give us our amount of root 3s. So 10 minus 3 is what? 7. And 7 minus 12. So remember, if we're going negative from 7, we're not allowed to just switch it over so we get a positive number. We have to go towards negative infinity. So we're going backwards 12 spaces. So if you put that in your calculator, 7 minus 12, you'll see that is minus 5 root 3 for our answer there. Okay, so question 2, it's again simplified this expression. So again, we're doing the last three, so H, I, and J of question 2. And as we can see here, that it's not all the same this time. So they've given us for this first question a mix of 13 and 7s, 5 and 11 and 3 for the second one, and 10 and 5 for the last one. So a good mix of things to do. Let's get started on H. So what have we got out the front of all of these? Let's do that first. So here we have a plus 1. Here we have a plus 8. And here we have a minus 7 and a plus 3. So now we're probably going to want to group them into little groups. So which ones are like terms? So we can see that that plus 1 and that minus 7 are like terms because they're both 13s. And we can also say that this plus 8 and the plus 3 are like terms because they are both 7s. So because we're plussing, again, we don't want to mix those different SURDs. So we're going to do these separately. So 8 plus 3 is going to be 11, lots of root 7. And we also have here our 1 minus 7. So again, tricky. We are on 1 and we're going backwards 7 spots this time. So 1, 2, 3, 4, 5, 6, 7. Or you could even think about it as minus 7 somewhere down here and going forward just 1 spot towards 0. So you'd have minus 6. So we have minus 6 lots of root 13. So you can write this either way. So just remember we have a plus 11 and a minus 6. So we can either write this as 6 root 13 plus 11 root 7, or you could even write it, if you really wanted to, as 11 root 7 minus 6 root 13. So they're both correct. So question I now, let's go through the same sort of thing. So the first thing we're going to do is we're going to write down each of our coefficients. So in this case, I can see that we have a plus 2, we have a minus 3, we have a plus 3, and we have a plus 4. So that's what all of these are out in front. But remember, we want to group them in terms of which ones are like terms and which ones are not. So this 2 and this minus 3 are both root 5s. Okay, we only have one lot of that root 11 there, the 3 root 11. And we also have that root 3 there. So usually when we have it all different SURDS, we want to make sure that none of these here can be simplified any further, and so we're going to check that these are all prime numbers. So 5's a prime number, we can't do anything with that. 11's a prime number, we can't do anything with that, and same with 3. So that is left in, it's pretty much, there's nothing more to simplify there. So if we were to group together these like terms, for the 5's, 2 minus 3, so remember we're on 2 on the number line, and we're going backwards 3, so we go past 0 and we get minus 1 lots of root 5. Okay, then we're going to have our plus 3 lots of root 11, we can't do anything about that, and our plus 4 lots of root 3. So that's our final answer there, and you can remember, you can rearrange it any way you like. Put that there, doesn't matter, either one's good. Okay, so Jay, let's go through this one more time. So we can see that we've got a plus 4 there, a minus 3, and a minus 4. Now before we go ahead, I just want to make note. So we have right now 10s and we have 5s. So the first thing that's coming into my head is maybe this 10 can be written as a root 5, and we know it can, but in order to get it like that, it would be root 2 root 5, so 4 root 2 lots of root 5, and that's just going to be annoying, so I wouldn't change it. So we can leave it in that form. So collecting our like terms again, we have a minus 4 for a root 10 and a plus 4 for a root 10. And then over here we have a minus 3 for that root 5. So collecting those like terms, we have 4 minus 4, which is going to be 0 lots of root 10. Okay, so if we have 0 lots, that means we've got none, so we can just cross that off, it doesn't matter. And we have minus 3 lots of root 5. So we don't need to include that bit. You can if you want, but it's a bit redundant, so I would not include it. And this here is our final answer, minus 3 root 5. Okay, so last question now, question 4. Remember, we're doing the last 3 of each question. So simplifying each expression again. However, this time, as we can see, they've given us quite ugly numbers. So we are going to need to simplify most of these first, unless we can see it's a prime number. So remember, in order to simplify, we want to take out a nice square number so that we can get it in the right form. So we're going to do x first. So I know root 27 can be written as root 9 times root 3 because 9 3s are 27. Okay, and there's 54. Usually the question is designed so one of these will come out. So I'm going to divide 54 by 3 and hope that it'll give me the right one. Yes, it does. So this 54 here is going to be root 18 times root 3. Okay. Now this root 18 here is not completely done because we can rewrite that as 9 times root 2. Okay, so let's go on to our last one, and then we have root 243. So 243, I'm going to try a few square numbers in my calculator. I'm going to guess 9 first. Okay, and I can see that does go in. So we have 9 times 20, root 9 times root 27. So root 9 times root 27 is the same as this 243 over here. So again, we're not done. So this 27 can go down, and we end up with our root 9 times root 3 again. Okay, now we're going to go through each of these simplifications, and we're just going to go through and find the square numbers we can rewrite. So root 9, what's that the same as? 3. So we have 3 root 3. Over here we have 9 again, so 3 root 2 this time. And then we don't forget this 3 up here, so root 3 again. Okay, and then we have 9 over here, so 3 root 3. Okay, now as we can see, they all have a root 3 in them. So what we can do here is we can take out a factor of root 3 and leave each of them like this. So I'm doing plus just because they're all pluses up here. So root 3, and then we have left over, if we take out the root 3, 3 root 2, and 3. So I've taken out that factor of root 3 now. Now let's just handle inside the brackets. So I can see that we got a 3 plus 3. So as we know from our adding and subtracting, we can do that easy. So that is 6 plus 3 root 2. Okay, and you could leave it like this theoretically, but I would say that the teacher probably wants it in the same form as we've been doing earlier. So then you can just multiply this back out if it looks better. So 6 root 3 plus, what's root 3 times root 2? It's root 6, so root 6, 3. So okay, so that would be how you leave your final answer. You could do it like this, but maybe like that. Okay, so let's go on to y now. Now, do we have any prime numbers here? We don't, so we're going to need to probably simplify each one of these. I'm going to start with the easiest one, the one at the end here, which is going to be minus 2 root 8. So minus 2, and root 8 can be rewritten as root 4 times root 2. Now, if I go on to this minus 3 root 20 I know also has a root 4 in it, because root 4 times root 5 equals root 20. So 3 lots of that, minus 3 lots of that. Okay, and if I do this 98, okay, so I can see that it's an even number, so I'm going to change that into root 2, and then I put that into my calculator. 98 divided by 2 gives us root 49. Okay, so we can see there's a fair bit of simplifying to do. So if we redo this, we can see that we have 7 root 2 here, because root 49 is 7. Now if we go through here, we have 2 over there. Okay, and then our root 5 is the simplest form we can get because it's a prime number. So minus 3 times 2, I have minus 6 root 5. And for this blue over here, I have, that's going to be 2. So 2 times minus 2, which is minus 4 lots of root. Now looking at the bigger picture, so are there any like terms in here? Now that this is all simplified down, I can see that there is a root 2 and a root 2 ready to be taken away. So I've got a 7 and a minus 4. So 7 minus 4 in my head is 3 root 2. And then there's no other root 5, so we can just add this in, minus 6 root 5. Okay, so our last question now, question Z. Okay, and we're going to do the same thing. So we've got this time a few bigger numbers, none of them are prime numbers, so I'm going to have to go through and do them as well. So let's start with this 96. Now I can't see the factor straight away, so I'm going to take out a factor of 2 and see if it helps me out. So 96 divided by 2 gives me 48, so that's root 2 times root 48. Okay, this root 48, I can divide that by 2 again. So 48 divided by 2 gives me root 24. So root 2 times root 2 times root 24. 24 still not even, so I can go 24 divided by 2 and I get 12. So I've got root 2 times root 2 times root 2 times root 12, and this root 12 still isn't done. So as you can see, it's probably been easier for me to take out a 16, but I'm going to keep going. So I then would have a root 2 times root 2 times root 2 times root 2 times root 6. Okay, now I know I could take out another 2 here, but because it would give me an odd number of surds and that wouldn't be very good, I'm just going to leave it like this. So root 2 times root 2 times root 2 times root 2. So remember, this is a squared and this is a squared, so that's going to be equal to 2, and this is going to be equal to 2 as well, and then that 2 times 2 is going to be equal to 4 root 6. Okay, so the 96 can be written as 4 times root 6, and then because we have a 3 out in front, we're going to put that 3 in as well. Okay, so let's go on to our second one now. So we have minus 2 and root 150. Okay, so 150, I can probably guess that 25 is going to go into that one. So 150 divided by 25, because that's 5 squared, and I get a root 6. So root 25 times root 6 gives me 150. Okay, and I have a minus 2 at the front of that one. So minus 2 times root 25 times root 6. And now for this last one over here, root 24, I can see that these are all root 6's, so I'm going to take a guess and say that they probably want me to take the 6 out. So I'm going to go minus 1. Remember that there's a minus 1 out in front there. They want to trick you with that one. So the minus 1 times root 4 times root 6, because 4 times 6 is 24. Okay, so we're going to go through and do our next step now, which is going to be going through and simplifying all of these. So I can see that I have 3 times 4 lots of root 6, so that's 12 lots of root 6 here. I have minus 2, and this root 25 is 5, so minus 2 times 5 is minus 10 lots of root 6 here. And down here, that's a 2, so I have minus 2 lots of root 6 down here. Now, these are all 6, so that means we can go through and just simply go 12 minus 10 minus 2. Okay, and if you put that into your calculator, you can see that that ends up as 0.